Hello guys, welcome to another video. Today we're going to work on topic 11, electromagnetic induction. We're going to solve a couple of multiple choice questions. So let's jump straight to the paper and see the solutions. Number 1. It says that X and Y are two plane coils parallel to each other that have a common axis. There is a constant current in Y. X is first moved towards Y and later is moved away from Y. What as X moves is the direction of the current in X relative to that in Y. So what we have here, we have this loop that a current it's always moving around, so it creates a magnetic field, and the direction of magnetic field, if you use the right hand rule, you're going to see that inside the loop it has this direction to the left. And what do we do now? We're taking this X loop and we move it either left, either right, and then we will have an induced current here in this loop, and also it's gonna create a magnetic field. Now we want to see what is the direction of the current of X. So let's say the situation that the loop X first moves to the right in this direction. Now, as it moves to the right direction, a current is gonna be creating here, and it's gonna create a magnetic field that it needs to oppose the change of magnetic field that it creates this current. So if the magnetic field is here on the left, we need to create a magnetic field to the right in order to oppose the magnetic field that creates this new induced current with a new magnetic field. So this is the magnetic field from loop X, and in order to have this direction of magnetic field, the current it needs to go like so, like this way around. So it's in the opposite direction of this one at Y. So definitely it's either C, either D. Now when you do the opposite, when you move it away from the Y, when you move it in this direction, the same thing will happen, but of course the opposite direction for both magnetic field induced and also the electric current induced. So at this situation it's gonna be in the same direction, and correct answer here of course it's C. Number 2. A coil is rotated in a uniform magnetic field. An alternating EMF is induced in the coil. What is the possible phase relationship between the magnetic flux through the coil and the induced EMF in the coil when the variations of both quantities are plotted with time? So what we need to find here is, first of all, we need to remember the relationship between the EMF and magnetic flux. And this is the one that it gives you, the relationship. So you see that the gradient of flux, in a graph of flux against time, it will give you the induced EMF. So when you have the gradient of this to be 0, then of course EMF will be 0. And where do we have 0 gradient? We have at the top here, 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 and so on. So what are we looking? We're looking that when the magnetic flux it has the maximum value, then the EMF it has the 0 value. So it cannot be A, it cannot be D. Now also we have this negative sign here. So when delta F over delta T, the gradient, it will be maximum, then I will have the EMF to be maximum, but of course with the opposite sign. So that means maximum gradient we have at these specific points. Here is the maximum gradient, here and here and here and so on. So when you have positive gradient, then you have negative EMF. So for example, here you see the gradient is positive, it gives you a negative EMF. When the gradient is negative, it gives you a positive EMF. It's the opposite here, so it cannot be C, so your correct answer here is B. Number 3. A capacitor of capacitance 1 microfarad stores a charge of 15 microcoulombs. The capacitor is discharged through a 25 ohm resistor. What is the maximum current in the resistor? So what we have to do here, we need to work with the formula of current with Ohm's law, that it says that current is the potential difference divided by the resistance of your element. So you know here that you have the capacitance of the capacitor and also you have the charge of the capacitor. With this formula here you can find the potential difference. So if you solve here for V, you have Q over C, so it's 15 microcoulombs over 1 microfarads. This will give you 15 volts. So if you replace here for maximum current, you have 15 divided by 25, of course it cannot be 1.7, it's 0.6 amperes, not milliamperes, because we don't have any prefixes here. So correct answer here is C. Number 6. Two charges plus Q and negative Q are placed as shown. What is the magnitude of the electric field strength in descending order at points X, Y and Z? So what we see here, we have this positive charge, it's going to create this kind of electric field away from the particle, and of course we have also the electric field at minus Q that it's towards the particle. So Z, you see, first it's here. So it has a very strong electric field from plus Q and a very noticeable field from negative Q, so definitely Z, it has the maximum electric field. It feels the maximum electric field strength. So all the other options, they are excluded. And if you see the Y and the X, the Y of course is closer to the other two particles. Of course, the closer that you are, the more field strength you feel from other objects. So of course, Y is first and X is last. So correct answer here is C. Number 7. The graph shows the variation with time of the magnetic flux through a coil. Which of the following gives 3 times for which the magnitude of the induced EMF is a maximum? So again here, we have to see the relationship between the magnetic flux and the EMF. So is this one, so you know when the gradient delta F over delta T, it is maximum, then you will have maximum EMF as well. So maximum gradient, these points here, here and here as well. Of course these points, they give you 0 gradient. So 0, T over 2 and T. Correct answer, it's B. Number 8. Two capacitors of 3 microfarad and 6 microfarad are connected in series and charged using a 9 volts battery. What charge is stored on each capacitor? So now what we have here, we have capacitors in series. So when they are in series, they store the same amount of charge because the same current charges them. So it cannot be D, it cannot be C. But now how much is this current? Well, in order to do that, we need to find first of all the total capacitance of these capacitors. In order to do that, we have capacitors that are in series, so the total, it will be the capacitance of one times the capacitance of the other divided by their addition. So you have 18 over 9, it gives you 2 microfarads. And in order now to find how much charge is stored, you have to solve this formula, Q over V. So you solve here for Q, it gives you C times V, so it's 2 times 9, so it is 18 microcoulombs, because we have this prefix here. So correct answer here is A. Number 9. The circuit diagram shows a capacitor that is charged by the battery after the switch is connected to terminal X. The cell has EMF V and internal resistance R. After the switch is connected to terminal Y, the capacitor discharges through the resistor of resistance R. What is the nature of the current and magnitude of the initial current in the resistor after the switch is connected to terminal Y? So after we turn here from X to Y, now our system, it's an isolated system, only this part. So what is happening here, the current is gonna flow in the direction, and you know, based on this formula, that the capacitor, it will start to discharge. So the charge here is going to decrease. If you decrease the charge, then the potential difference also is going to start to decrease. Now, based on Ohm's law, for the current, if the potential difference will start to decrease, then also the current, it's gonna decrease here in the resistance R. So definitely the current is decreasing. Now, the relationship, the magnitude of initial current, of course, it cannot include any small r here for internal resistance. It's an isolated system. And of course, you can see it from here, which one is the correct formula. Of course, it's number C, the correct answer. For number 10, it says that the input to a diode bridge rectification circuit is sinusoidal with a time of period 20 milliseconds. Which graph shows the variation with time t of the output voltage V out between X and Y? So we're trying to find here the potential difference in the resistor. Now, based on these graphs, you see that the current, it will flow from whichever direction it will start. Based on these diodes here, it will flow from this direction. Either that way, it will flow again from the same direction. So the direction of the current will always be the same. So we cannot have this kind of graphs that they give you also zero current when it passes from the other direction, like zero output. So it's either A, either B. And of course you have a period of 20 milliseconds. So 2 times in a period of 20 milliseconds you have to have maximum output. So of course it's number A. Number 11. 3 identical capacitors are connected in series. The total capacitance of the arrangement is 1/9 millifarad. The 3 capacitors are then connected in parallel. What is the capacitance of the parallel agreement? So let's see what we have here. First of all, we have 3 capacitors in series, identical ones, so they have the same capacitance C. And then we arrange them in parallel. So first, we need to see we need to figure out the individual capacitors in this arrangement, in the series one. And then we're going to see what we have in the parallel arrangement. So here, if they are in series, that means that the combined capacitance, it is given by this formula. So now what I have to do, I have this 1 over Ct, it's 1/9, and I have 3 identical ones, so it's 3 over C. And now I need to solve this equation. So if you do the math here, you will find 9 is equal to 3 over C. So that implies that C, it is equal 3/9, so it's 1/3. The capacitance of each one individual one. Now when you arrange them in parallel, what do you have? You have the total capacitance to be given by this formula. So you have the total capacitance to be 1/3 plus 1/3 plus 1/3. So in the end, it gives you 1. And this is the new capacitance that you try to find. So of course it's 1 millifarad, answer B. So number 17, it says that the graph shows the variation of the peak output power P with time of an alternating current AC generator. Which graph shows the variation of the peak output power with time when the frequency of rotation is decreased? So what we have here? Here we have decreased frequency. So if we decrease the frequency, then we increase the period. So if I see a period of 2 seconds here, now on my graphs, I need to see a period of bigger number. So it cannot be A, it cannot be B, it's either 4 here, either C, either D. Now also you know that when we decrease the frequency, the velocity, it needs to decrease, the velocity of rotation. So that means that the power is given by this formula. So the potential difference in the current, they will decrease as well. So the power, it will decrease also. So from here you can see that we have to have smaller power than before. It cannot be D. The correct answer is C. And number 18, a current of 1 times 10 to the power of -3 amperes flows in the primary coil of a step-up transformer. The number of turns in the primary coil is NP, and the number of turns in the secondary coil is NS. One coil has 1000 times more turns than the other coil. What is the NP over NS ratio, and what is the current in the secondary coil for this transformer? So what we see here, we see that we have a step-up transformer. So that means that the secondary coil, it has more turns than the primary one. So from here you know that one coil has 1000 times more, so that means that the NS it's 1000 times the NP. So from here you see if you take the ratio NP over NS, it will give you 1 over 1000. So correct answer is either A, either C. Now we need to see what is happening with the current, and we have to use this formula that says that the current in the secondary over the current in the primary is equal with the number of turns in the primary over the number of turns in the secondary. So from here, you know the IP, you know NP and S, the ratio at least, so you have to solve for IS. So this would be 1 times 10 to the power of negative 3 amperes for the IP times 1 over 1000. So from here, if you do the math, you will see that IS is going to be 10 to the power of negative 6 amperes. So of course it's either A, either D. Correct answer here is A. So that was all for today, guys. Study hard and good luck.